Hello everyone. Today we'll be going through Cambridge International AS A-Level Mathematics Paper 4 Mechanics 970943 May June 2021. So let us go to question number 1. Question number 1 says particles P of mass 0.4 kg and Q of mass 0.5 kg are free to move on a smooth horizontal plane. P and Q are moving directly towards each other. So I have inserted this picture for your explanation, and arrows are showing the direction of movement. They are moving towards each other. This is what diagram is also indicating. And we can take P, which is 0 point, P point, we can take this one, and Q we can take this one. So 0 point M is equal to 0 0.4 kg, and in Q's case M is equal to 0 0.5 kg, are free to move on a smooth horizontal surface, so there is no friction. P and Q are moving directly towards each other with speed, and speed is 2.5 and 1.5 respectively. So 2.5 is in case of V. We can write V is equal to, this will be 2.5 and 1.5. So we can take this color, so it will be 1.5 will be in case of Q, which is meter per second, and this will be P, which is 2.5 meter per second. This is the velocity. This will be what? After P and Q collide, the speed of Q is twice the speed of Q. So after collision, this is like collision we can see, and then velocity is so after collision situation, we will discuss, first of all, we will be discussing before collision situation and find the two possible values of speed of P after collision. So we will be discussing before collision and after collision situation. So momentum before collision will be 0.5. This will be the mass m1, and v1 will be, we can take right side as negative direction, so minus 1.5, and plus this will be the momentum of other, will be mass will be 0.4, and multiply by its mass, this will be 2.5. So this will be the momentum before collision. So we can write here momentum before collision. So momentum before collision is this situation. Now momentum after collision can be two situations. One situation is that they are moving in same direction, like this diagram. So they are moving in same direction. So we can write same direction. So if they are moving in same direction, then what will be the situation? We will equate this momentum which we have written over here. We will rewrite 0.5 into minus 1.5 plus 0.4 into 2.5, and this will be equal to 0.4 multiplied by V. This will be 0.4 will be moving with the velocity V. So this is velocity V, and the second one, which is 0.5, so this will be moving with velocity double of V, which is 2V. So this will be moving with 2V, and we can write here plus, this will be momentum of this will be 0.5 into 2V. This will be the situation. If they are moving in same direction, we have taken both as same sign, with the same sign. So this will be, now we can find the value of v. We can write here, like for example, this is 0.5v plus this will be 1v, so it will be v, and this side will be, we can calculate this side, so it will be 0.5 into, in brackets, minus 1.5, and this will be equal to minus 3 by 4, minus 3 by 4, and plus this will be 0.4 into 2.5 is equal to, this is 1, so 1 minus 3 by 4, minus 3 over 4 will be equal to 1 by 4. So 1 by 4 will be, and this side will be 1.4v. So we can write v is equal to 1 we can write 1 over 4, and this will be divided by 1.4, so we can rewrite, multiply this by 1 over 1.4, and this will be resulting to 5 by 28. We can write as 5 over 28, and decimal value will be 0.1785, 0.1785, and up to three significant figures, 0.179, we can provide. This is in case of, this will be, units will be meter per second, and this will be in case they are moving in same direction. Now the other situation which we can discuss is over here, which is if they are moving in opposite direction, and we can take it as opposite direction. So in that case, momentum equation will be what? This will be 0.4. 0.4 will be multiplied by 2.5 plus 0.5 will be multiplied by minus 1.5, and this will be equal to 0.4 into, this will be minus v. Now this direction we can take as minus v, and this one as 2v, so it will be minus v plus this will be 0.5 into v, so into 2v, basically this will be 2v. So this will be our equation, and we can simplify to solve this one. This whole thing we can write in calculator, and we can get the answer in one go. So it will be 0.4 into 2.5, and plus this will be in bracket, this should be 0.5, so 0.5 into minus 1.5, and this is equal to 1 over 4, or decimal value 0.25. We can write 0.25 on this side is equal to, this will be minus 0.4, and this will be 1, so 1 minus 0.4 will be 0.6 v. Now v will be equal to 0.25 divided by 0.6, and 0.25 divided by 0.6 will be equal to 5 by 12, 5 over 12, and decimal value we can write it as 0.4166, 0.4166, so up to three significant figures, 0.417 we can write, this will be meter per second, this will be the velocity in case they are moving in opposite direction. So we have discussed both cases basically. Now question number 2. Question number 2 says a cyclist is traveling along a straight horizontal road. She is working at a constant rate of 150 watt at an instant when her speed is 4 meter per second, her acceleration is 0.25 meter per second square, the resistance to motion is 20 newton. A part, find the total mass of the cyclist and her bicycle. So this is 3-mark question. If we roughly draw a small diagram to understand this. So like for example, this is the cyclist. There will be two forces. One will be the driving force, which is say on this side, and there will be a resistive force also, and a resistive force will be on this direction, opposite direction. So resistive force, or Fr, we can write Fr, resistive force. Now this is the situation, and uh, driving force of cyclist will be, we can calculate driving force of cyclist. So driving force of cyclist will be equal to, we can move a little down, so this will be equal to 150 Newton watt. This one is it's watt, so divided by 4 meter per second. This is the speed, so this will be equal to we can calculate, this will be 150 divided by 4 is equal to um, 37.5. So 37.5 newtons, this will be the force, and we can apply F is equal to ma Newton's second law. Driving force minus the resisting force, this is a positive direction, and this one we can take as negative. So driving force minus resistive force will be equal to ma, which is mass, into acceleration. Basically acceleration is provided 0.25, so we will write ma, which is equal to m into 0.25. so this side force is what, this is 150 by 4, this will be the driving force, and the resistive force is 20 newtons. This is mentioned in the question, so minus 20 is equal to, because it's opposite direction, 0.25. M will be the mass, so mass we can calculate from here, and mass will be equal to 150 over 4 minus 20, and this will be divided by 1 over 0.25, and we can calculate, so it will be 1 over 0.25, and this will be multiplied by 150 over 4 and minus 20, and this will be equal to 70, and 70 mass will be in kgs, so this will be our answer for this part A. Hopefully you understood this. Now we can move to the part B, and part B says the cyclist comes to a straight hill inclined to an angle theta above the horizontal. She ascends the hill at constant speed of 3 meter per second. She continues to work at the same rate as before, and the resistance force is unchanged. Find the value of theta. So to understand this, we can draw a small rough drawing, and that one we can draw like this one. So this is the inclined plane which we have drawn, and this is making an angle of theta with the horizontal, and say cyclist is over here, and the mass will be acting, weight, basically weight will be acting downward, and this will be W, which is equal to mg, and we can understand the driving force. So its driving force is upwards, so this is driving force, and the what do you call, the resistive force will be on this side, Fr will be on this side, and now we can resolve this along the inclined direction. So we can resolve this force like this one over here. We can resolve this force parallel to the inclined direction. So this will be our theta, and we can take this as mg sine theta, and this component will be our mg cos of theta. This is what we are splitting the vector, basically the w into mg sine theta and cos theta. Now we are done with the drawing. Now we can see this one driving force is on the one direction, and this component and Fr is on the other direction. So we can write as driving force is equal to what? This is equal to Fr plus mg sine theta. Mg sine theta. We have resolved along x-axis. So Fx, we are resolving the forces along x-axis, and this will be equal to 150 over speed, which is 3. So this is the speed given. 150 over 3 will be equal to 20 Newton is the resistive force, and mg we just calculated, m is 17 to 10, so it will be 700, and sine of theta. Basically we are required theta value, so we can now shift everything to other side. So sine theta will be equal to 150 over 3 minus 20, and this will be divided by 1 over this one, divided by 700 basically. Now we can calculate this. It will be in brackets 150 over 3, and this will be minus 20 and bracket close, and this will be multiplied by 1 over 700, and this is equal to 3 over 70. So we can write theta is equal to sine inverse of 3 over 70, and we can rewrite this as basically we can check sine. There is shift sine of this angle answer will be equal to this is in case of radians, we just change shift mode into degrees, and this will be equal to 2.457. so theta is equal to 2.457. You will have to be careful that your calculator should be in degree mode for this question, so accordingly you can switch. So this will be theta will be equal to 2.5 degrees, and this is equal to 2.5 degrees. This is what we have found in this case. Now we can move to the question number 3. Question number 3 is interesting. 4 coplanar forces act at a point. The magnitude of forces are 20, 30, 40 and F newtons. The directions of the forces are as shown in the diagram, where sine alpha is given. So sine alpha is given, so we can, from this we can find alpha value, and that we can use for cos alpha also. So sine beta is also given, so same is the case for the beta. We can check for the beta value, and we can utilize for cos also. So given that the forces are in equilibrium, find F and theta, and this is 3 marks question. So first of all, we will be resolving the forces, and the first force which we are resolving is this 40 Newton force. We can divide into its components. So one component will be this one, and this will be along y-axis component, and x-axis component also we can draw, and this is x-axis component, and it is acting towards the left. And now we can resolve 30 Newton force as well, and 30 Newton force also we can resolve. This will be the y component, and the x component also we can draw. Hopefully you are following each and everything, and keep in mind you have to press bell icon and subscribe the channel also. Okay, so this will be x-axis, direction 30 Newton, resolution of forces for two forces we have done. For the remaining two forces also will resolve into components, and 20 Newton force which is acting along 60-degree angle, this will the force, and this will be the y component. This will be the y component, and x component I will draw a little above so that you can see the color. So this will be the x-axis, x force. Now the last force which is remaining, we can resolve that force as well, which is F newtons. And so if we draw like y-axis will be this one, hopefully you can see this is y-axis, and this is along x-axis will be this for small color change you can see hopefully. Now we can resolve the forces along x-axis and y-axis, and to resolve, first we will resolve y-axis, and I want to see the drawing also, this one. So we can write along y direction, this will be f sine theta. So what is f sine theta? Basically I'll have to write over here also. So this is our sine alpha, so we can write 30 sine alpha, basically 30 sine alpha, and this y-axis force will be 20 sine of 60 degree, and this force will be 40 sine of beta, 40 sine of beta, and this force F will be f sine of theta. So f sine of theta. Now we got basically these all y components. These are four terms which we'll be writing. So rightward forces are these two, 1 and 2, and we can write first the forces which are in right direction, and then we'll be for writing on the left direction also. Basically not right left, up and down. So sorry, because we are resolving in y direction. So upward forces are what? Upward forces are this one and this one. So these two forces I will write, this will be f sine theta. I'll change the color. So normally this one we are using, so f sine theta and plus 20 sine 60 degree, and coplanar forces are acting at a point, the magnitude of this one, the direction of forces in diagram, and this one, and see this one they have mentioned that it is in equilibrium. So because they are in equilibrium, so upward forces will be equal to downward forces, and downward forces are what? Number one, 40 sine of beta and plus 30 sine of alpha, plus 30 sine of alpha. Now what else we need to find? Basically we need to find sine alpha value. Sine alpha value we have, but sine theta value, okay, sine alpha value we have, we will just replace, but sine beta value also we have. So sine alpha, sine beta, we can use both values and we can find sine theta. So f sine theta is equal to what? This will be equal to 40 sine beta, and sine beta is 0.6, so 40 into 0.6 and plus 30 into sine alpha, so it will be 0.28, and minus 20 sine of 60, which we have shifted to the other side. Now we can directly find f sine theta value. F sine theta value will be, by the help of calculator, 40 into 0.6 and plus 30 into 0.28, and minus this will be 20 sine of 60 degree, and this is equal to 15.079, 15.079, if I write the whole calculator digits, so 49,192, 49,192. So this will be our f sine theta value. Now we can find for basically we can resolve along x-axis we have done. So x-axis will be for each value it will be cos theta, so this will be 30 cos of alpha. Similarly, this force, which is this one, will be 20 cos of 60 degree, and in this case it will be f cos of theta, and in this case this force will be 40 cos of beta. So we have written all the four forces, which are two forces are to the right direction, which is this one and this one. So cos theta and 40 cos beta, these two are to the left direction. So we can write over here f cos theta plus the other force is f 40 cos beta. So we can write 40 cos of beta, and this is equal to the other two forces, 20 cos of 60. We can check from here, 20 cos of 60 and 30 cos alpha. So we can write 20 cos 60 plus 30 cos of alpha. Now we have basically we have sine alpha is equal to sine alpha is given, sine alpha is equal to 0.28, and sine beta is equal to 0.6. So this one we can utilize, like for example alpha is equal to sine inverse of 0.28. We can check, and we can check for beta also. Beta will be equal to sine inverse of 0.6, and these values will be helpful for us, which we can use for the cos angle. These will the angles which we'll be using for cos. So shift sine of 0.28, and this will be equal to 16.26. So 16.26 is alpha value, and beta value will be sine of 0.6, and this is equal to 39.87. So 39.87 degrees. These are the two values of alpha and beta. Now these alpha and beta we can replace in this equation, and our equation will modify to f cos theta plus 40 cos beta. So cos of 39.87, and this is equal to 20 cos 60, and plus this will be 30 cos alpha, so cos of 16.26, and this one. Now we can shift this 40 cos 39.87 to the other side, and this will be giving us f cos theta is equal to 20 cos of 60 degree plus 30 cos of 16.26 and minus 40 cos of 39.87. This one, if we check the value on the calculator, is 36.87, and by mistake I have written here 39.87, so I will rectify this 36.87, and this will be 36.87, and this one will be 36.87. Hopefully you understood everything. Now it is rectified. Now we can use calculator to simplify this expression, and this will be 20 cos of 60 degree, 20 cos of 60, and plus 30 cos of 16.26, and next is minus 40 cos of 36.87, 36.87, and bracket close, and this is equal to 6.8. So we can write here 6.8. So this will be f cos theta. So we got f sin theta, f cos theta. So theta will be equal to tan inverse. Theta is equal to tan inverse of y value over x value. So y value is what? Y value is this one. Basically 15 point this. So 15.15, we can write fraction 15.079 079 and divided by 6.8. So divided by 6.8, and this will be equal to tan inverse. We can check shift tan of 15.0794 and divided by this will be 6.8. Sorry, bracket should be, this bracket should be over here, and this will be 65.727, 65.727, which is 65.7 up to 3 significant figures. So this will be the theta value. Now we can find the force also, resultant force. So what I will do, I will reduce this a little size so that we can get more one step space for this one, and this is like readable size. Now we can find f will be equal to under root of fy square, so which is 15.0794 squared and plus 6.8 squared, and this will be value of f, and we can write square root of 15.0794 squared and plus 6.8 squared, and this will be equal to 16.5, 16.5 up to 3 significant figures. This will be force, so newtons, and this is done. Hopefully you understood each and everything. Now we can move to the question number 4. Question number 4 says a particle is projected vertically upwards with speed u meter per second from a point on a horizontal ground after 2 seconds. The height of the particle above the ground is 24. Show that u is equal to 22. This is a 2 marks question. So we can understand this, like for example this situation, it will be helpful if we draw a little. So it's moving like over here up to this one, and this is the so s is equal to u is u meter per second. So velocity is u meters per second, and time t is equal to 2 seconds. So 2 seconds, and what else we have? The 24 meters is the distance, so distance is like this one, so this will be 24 meters. This is the situation. Now we need to find the value of u. So we have s value, s is equal to ut plus half at square. A will be minus 10. We can write meter per second square. So this will be acceleration. So s is equal to, we can change the color, so it will be s is equal to ut plus half at squared, and s is 24 is equal to u, and t value is 2 plus this will be half into a is minus 10 and t value is 2, so 2 squared, and this will be equal to 24 is equal to 2u. 24 is equal to 2u minus this will be 2 into this will be 5, so after this 5 will be 20, so minus 20, and 2u is equal to 24 plus 20, and this which is equal to 44. So u will be equal to 44 divided by 2, which is equal to 22. This will be meters per second. This will be value of u. Hopefully you understood this. Now we can move to the next part, which is B part. The height of the particle above the ground is more than h meters for a period of 3.6 seconds. Find h. So we can understand this again by drawing a diagram, like rough sketch, a rough drawing. So this is like maximum height which it is attaining. So this we can write maximum level it is reaching to. And like for example, after it's remaining for 3.6 seconds above height h. So height h, we can suppose height h is like this one is height h, and so above this level is what, when it will be moving above to the maximum level, it will be going this route, and then it will be returning also and covering the same distance up to this level. And this will be, this double route is taking t is equal to 3.6 seconds. So half for one side, it will be t is equal to 1.8 seconds. Hopefully you understood this. So total time is 2 seconds, and u is the velocity, which we have done in the previous part basically. So, and s, which is 24 meters, this is the previous data. So now we can understand u is equal to what, u is equal to the same 22 which we just found in the previous part, so meter per second, and a is equal to minus 10 meter per second square, and always write with units. So t we need to find, and we can write v is equal to u plus at, and final velocity at maximum point will be equal to 0. So we can write 0 is equal to 22, and this will be plus and minus 10 into t. So total time taken will be what, total time will be equal to uh, this will be what, this will be 22 divided by 10, which is equal to 2.2 seconds. So 2.2 seconds is the time of flight of this whole journey. And like time of flight means going maximum to reaching to the maximum level, you can say. From this point to this point, it is taking 2.2 seconds, 2.2 seconds to reach to the maximum level. So from this one we will subtract, so time above h will be how much. So we can write time above h, and this will be equal to 2.2 minus the time, which is 1.8, so 1.8 seconds, and this will be equal to 0.4 seconds. 0.4 seconds. Now we have to check in 0.4 seconds how much distance it has covered. So s is equal to ut plus half at squared. Now if we replace values, s will be equal to, we can, s is equal to, u will be 22, t will be 0.4, and plus half into acceleration will be minus 10, and t square will be 0.4 squared. And if we calculate this with the help of calculator, we will get 22 into 0.4 and plus 0.5 into minus 10, and in brackets 0.4 squared, and this will be equal to 8. So s is equal to 8 meters. This will be our final answer for this question. Hopefully you understood each and everything. Now we can move to question number 5. Question number 5 says a car of mass 1400 kg is towing a trailer of mass 500 kg down a straight hill inclined at an angle of 5 degree to the horizontal. So far whatever we have gone through question, we will be drawing a rough drawing for that one, so we can consider like this angle is more, but I'm drawing a little more angle so that you can understand the clearer concept. So this angle, let us suppose this is 5 degrees as provided, and car is this one is car, and we can consider this as car, and this is like trawler, and so trawler is like this one, so this is trawler, and they are saying the car and trawler are connected to a light rigid bar at the top of the hill. Speed of the car and trawler is 20 meter per second. So speed is 20 meter per second. So u is equal to 20 meter per second, and at the bottom of the hill the car speed is 30 meters per second. So at the bottom mean final velocity, so final velocity is equal to 30 meter per second. This will be at the bottom of the hill. Next, a part says it is given that as car and trailer descend the hill, the engine of the car does this much joules of work, and there are no resistance forces. Find the length of the hill. So hill, this one, height of the hill, we can check. Height of the hill will be this side, and this height will be, this height we can take as h, and this will be opposite over hypotenuse, so it will be s. This one 5 basically, uh, theta value will be 5. So s is the distance, and that distance will be from this position to the top of the hill. So this will be rs. So h over s uh, will be equal to sine 5 degrees. So we can write h is equal to s sine 5 degrees. Hopefully you understood this. Now we know that energy is lost. S value we have to find. S value we have to find. So this is the given data which I have copied closer to the drawing so that you can understand each and everything. Now we know that gain in kinetic energy is equal to, when it is moving from top of the hill to the bottom, it is from the top to the bottom, it is gaining kinetic energy and losing potential energy. So gain in potential energy will be equal to of loss of potential energy. Sorry, gain in kinetic energy. Gain in kinetic energy will be equal to loss of potential energy. Now gain in kinetic energy will be what? Half mv square. So half mv square will be change in velocity. So v square minus u square. Half m, this will be half m, and this will be velocity. So this will be equal to mgh we can write, and this will be equal to half into mass. Collective mass will be 1400. 1400 plus 1400 and plus 500, and change in velocity will be 30 minus 20, 30 squared minus 20 squared is equal to mass, which is again the same. Mass will not be changing because car and troller both are same or not changing. This one into G value, so going down, so G will be this one, and H we need to find. Basically G will be taking, H will be H sine of 5 degrees, so we will write S sine of 5 degrees. Now this will be our equation, and plus what else is being done, this much work is also being done. So this work done we have to add on this side. So this one is what? This one I will write for your understanding. I'm writing work done. Now we can solve this equation, and this will be what we can do. We can use calculator directly to solve 0.5 into 1400 plus 500 bracket close into 30 squared minus 20 squared, and squared we have not written squared, and this will be equal to 475,000, 475,123,000, and this side we can also simplify, and this side will be 1400 plus 500 plus 500, and this will be 1900 multiplied by 10, and this will be equal to 19 and 3 zeros, and S sine 5 degree plus this one 151234 zeros, and now we can shift this to the other side, so it will be 475,000 minus 151234 zeros, and this one 19,000 also we can shift to other side, so it will be 19,000, and sine of 5 also we are shifting, so we'll be getting S only. So we can write the fraction, and it will be 475,000 minus 1540 divided by 19,000, this one, and multiply by sine of 5 degrees, and this will give us 196.26. So S will be equal to 196.26, so we can round it to 196, and this will be in meters. This will be S value, so S value is basically 196 meters, which we found. Hopefully you understood this A part. Now we can move to the B part, and B part says it is given instead that there is a resistance of 100 Newton on the trailer. The length of the hill is 200 meters, and the acceleration of the car and the trailer is constant. Find the tension in the uh, tow bar between the car and the trailer. This is also 4-mark question. So we can first we have to calculate the acceleration, because acceleration is constant and it is not given, so we have to calculate. So final velocity we have, initial velocity also we have. So final velocity is equal to 30, initial velocity u is equal to 20, and what else we have? We have S also. S is equal to 200, and we need to find A, so we can write V square minus U square is equal to 2AS. So this given data will be incorporating in this equation, and we'll get 30 squared minus 20 squared is equal to 2A, and S is 200. So A will be equal to 30 squared minus 20 squared divided by 400, and this will be the acceleration 30 squared minus 20 squared divided by 400, and this will be equal to 5 by 4, or we can write 1.25, and its acceleration, so meter per second square will be the units. Now we will apply Newton's law on the trolley, so on the mass basically which is moving, car and troller both, and it will be Newton. When we apply Newton's law, second law, so tension minus 100 Newton resistance, force is on the opposite direction, so it will be minus 100, and plus we will take weight will be basically, see from here you can understand, tension will be on this side, tension will be on this side, and mg sine, if we take basically mass of the trailer is this one, so mass of the trailer will be acting downward, which will be w, which is mg, which is equal to mg. So we can resolve this into two components like this, so this will be 5, and we can take this will be component x component, which will be mg sine of 5 degrees. So this mg sine of this one, mg sine of 5 degree, will be along the tension side, and the resistance will be on opposite side, which is this one. So that is that 100 basically is the resistance, which we already know. This is 100 resistance opposite direction. So this will be, we can write like this one, so t minus 100 plus 500 weight of the trolley into g, and sine of 5 degree, g will be 10, you can replace 10 here, and 5, this will be m into a. Now this we will be replacing basically, we can apply tension, basically we can write tension is equal to what, tension is equal to 500 into 1.25 acceleration, which we just now replaced. This what we can do, we will replace in this equation first, minus 100 plus this will be 500 into 10, sine of 5 degrees is equal to 500 into 1.25. So after replacing values, we'll directly get tension. Tension will be equal to these terms will be shifting to the other side. So we'll get 500 into 1.25, and this will be plus 100 and minus 500 into 10 sine of 5 degrees, and t will be equal to what, this will be 500 into 1.25 and plus 100 minus 500 into 10. I'm typing exactly in similar ways, and so that you can understand. So this is 289.22, 289.22, and this is in newtons, so we can round it to 289 newtons. This will be the tension which we are supposed to find. Hopefully you understood each and everything. Now we can move to the question number 6. Question number 6 says a particle moves in a straight line and passes through the point A at time t is equal to 0. The velocity of the particle at time t is after leaving A is v meter per second, where this equation v is given for v. A part, find the time at which the particle is instantaneously at rest, momentarily at rest, hence or otherwise find the minimum velocity of the particle. Now this is the section which I have added. I will explain this section. This is not part of the questionnaire. Now we can understand basically, first what we will do, we'll try to draw a simple sketch so that we can understand the situation properly. In mechanics, always if you are drawing a small diagram, this will be very helpful for you to understand the situations. So this will be a position, and this is position at t is equal to 0, as they have explained at t is equal to 0 point A, and it after t seconds, when t is equal to t seconds, it reaches at this position, um, v velocity. So at this point velocity, it is v meter per second, and this is basically the thing. So at v is equal to 0, at v is equal to 0, what will be t value if we replace basically v is equal to 0? If we replace over here, we will get what? We will get 2t. I will change the color. So 2t squared minus 5t plus 3. So this will be momentarily at rest, it means v will be 0, so that's why we are taking this one as 0. And this one we can solve this quadratic equation, and this will be mod 5 3, and coefficient of t square is 2 and coefficient of t is minus 5 and constant value is 3. So this will give us 3 by 2 and 1. So t minus 1 and 3t minus 2 is equal to 0, and these will be the factors, and we can write this, basically we can write this t is equal to 1 and t is equal to 3 by 2, which we can write as 1.5. So this will be the situation. Now we can take, I will reduce the size, including this also. I will reduce the size so that we can get more space for this, and to the readable size, and move and keep here. Hopefully it will be no issues for you. And now we can take velocity, which is what? 2t squared minus 5t plus 3. So we will find basically acceleration. We know acceleration is 0, momentarily 0 for this velocity. So we will find acceleration from this equation, and that will be dv over dt, and derivative of this will be 4t minus 5, and we know the derivative will be 0, so we will put equal to 0. T will be equal to 5 by 4, or we can write it as 1.25 seconds. This will be the time. So time 1.5, this time we can basically replace, and we can write velocity at t is equal to 1.25. This will be equal to 2 into, we are replacing in this equation, 2 into 1 plus 1.25 squared minus 5 into 1.25 and plus 3, and this will give us what we can simplify by the help of calculator. So this is 2 into 1.25 squared minus 5 into 1.25 bracket close and plus 3, and this is equal to minus 1.8, or what we can do, we can write decimal value minus 0.125 minus 0.125. This will be the velocity, and it is negative in direction. and the units of this velocity will be meter per second, which we can write over here. And now B part says sketch the velocity time graph for the first 3 seconds of motion. So for this section, basically I kept this drawing. I will move over here and we will discuss in a while. Now we can sketch this and the equation. We can write down the equation, which is V is equal to, if I write over here, V is equal to 2t squared minus 5t plus 3. So this is basically the equation which we will be utilizing. And to sketch this curve, what we can do, we can draw coordinate axis like this one, and this will be velocity time graph. And if we draw, this will be velocity side, and this will be in meter per second, and this will be time side, and this will be in seconds. So now this will be the origin and or 0 0 location, and now we can take like units. We can take this side as like 1 and 2 3 4 5, like this one, and this side we can take a smaller height, so 1 2 3 and 4, like this one. So this side is 1 2 3 and 4, and this side is 1 2 3 4, and this will be 5. So this one will be 5 over here. So now what we can do, we can use our calculator help for this one. We can just type the equation 2, and this will be x squared, so x squared minus 5x and plus 3. So this is our equation. So t is equal to when t is equal to 0 or x in this calculator equation, calculate for x is equal to 0, we will get 3. So we got the point which is 0 and 3. So this point is one of the point which is we are drawing, and we know this is quadratic graph. T square is the it's in the form of ax square plus bx plus c. So this is the general form of quadratic equation, and the coefficient of t is 2, which is greater than 0, and it means that curve is opening upward u-shaped graph. So these are the informations which we got from this one. So it will, now we will be checking whether it is and we have 2 points over here which we have solved. This t is equal to basically 1 and 1.5, these 2 points. So 1 and 1.5 are the points of intersection. So 1 will be over here, and 1.25 basically, um, and what 1 and 1.5 basically. So this will be 1.5 we can take over here, and this is basically the other point of intersection. Now in between these two also we can check, calculate for 1.25. So x value 1.25 will be giving us minus 0.125. So a little lower, like over here we can take this one, and next value we can take on the right side of this basically we can take 1.6 or 7, something like that. So calculate for 1.6 will be equal to 0.12, so we can take some bigger value. So we can take 2, x is equal to 2 will give us 1. So x is equal to 2 is giving us 1, so it will be like this one, 2 and 1, and now we can take more than 2, so we can take 2.5. So calculate for 2.5, this will be 3. So 2.5 is 3, so we can take 2.5 basically. 2.5 and 3 will be like over here, a little lower than this. Okay, so this one. Then for 3 also we can check, calculate for 3, and this will be equal to 6, which is going up. So we can take like we can move a curve like this one, and 6 we will be taking up. So now we can draw the curve. It will be curving, quadratic graph is curving like this one, and bending from here and moving like this, and curving like this one up. And this is how we can rectify basically this portion of the curve, and this will be like over here, and curving like this one and this one. Almost sketch we have shown. Basically these are the points which we are showing. This is 1, this is 1.5, and this point will be 1.25, and we can give this point as basically 2.5 and 3, and this point is, these are not required, this point and this point are not required. I'm writing for your understanding. So this will be 2 and 1. So and these are basically points of intersection will be required. What are the points of intersection? X-intercept and Y-intercept. So that's all, we are done with this. But the thing is that if you will be practicing these type of questions, graph questions and transformation questions, with the help of any software, which are so many softwares are available on net, so we can switch and discuss there. So this is the software which I'm using. You can use any other software, and plus you should keep in mind that this software or any other software will not be allowed in exam. You will have to practice it at home, and you will have to improve your skill level so that you can tackle these type of questions during examination. And this is the equation which I have written: y is equal to 2x square minus 5x plus 3, and if we draw this one, you can see this will be the curve, and this is 0 and 3 and y-intercept, and this is 1 and 0, 1 and 0, 1 and 0, and this is 1.5 and 0, the same points we got as x-intercepts. And this is a little lower, the minimum point of the graph, which is 1.25 and minus 0.125. You can see this is quadratic graph, which is having exactly same shape as we have drawn. And the other point, which basically we got 2 and 1, this point is we can move to basically this one. This is the 2 and 1 point, and 3 and 6 point also we can figure out. This will be, if we move to exactly at 3, this will be 3 and 6. Now it is at 3 and 6. So because this is not point of intersection, so it's giving temporary value till the time I'm pressing the mouse. So it is 3 and 6, and this is how you can practice and check the exact shape of the curve and understand how things are happening. Let us move back. Now this is basically the curve which I have copied, the same curve, and if we understand this curve, so this is the curve which is having, this is y-intercept, and this one is y-intercept, and this is 0 and 3. As you know, we got by replacing t is equal to 0, and this side is velocity, and this side is time, or time, and this is origin, and this is 1 and 0, this point is 1.5 and 0, and this minimum point is 1.25 and minus 0.125, which we exactly got. This one is we can exactly write the complete point also, 0.125. We got this value basically on the calculator also. Hopefully you understood each and everything. Now we can move to the next question. Next, C part says find the distance. So velocity equation is given, we know to integrate and find the distance. So find the distance traveled between the two times when the particle is instantaneously at rest, and we got those 2 points basically. Instantaneously at rest was at t is equal to 1 and t is equal to 1.5. so these I have already calculated closer to the drawing in part A, and now we can integrate. We have equation v is equal to 2t squared minus 5t plus 3, and we will be integrating, and integral of v will be x, and we can write integral of 2t squared minus 5t and plus 3, and this will be dt. And now we can integrate this, so it will be 2t raised to the power 3 over 3 minus 5t squared over 2 plus 3t. This will be the integral, and integral limit we forgot to take, and this will be 1 to 1.5 we can write. So integral limit we can write 1 to 1.5. Now we can replace the values, and values also we can replace by the help of calculator. So what we can do, we will type this equation. So 2 over x, if you are feeling easy, you can directly replace the values, and if this is just another way which I'm trying to explain so that you can use this method also. And once you are done with the typing of the equation, then as many as you want, you can find the values. Basically this will be alpha x, and it should be square also, and next is plus 3 and x. Now we have written this equation exactly as we are having here. So now we can calculate for 1.5, and this will give us 9 by 8. So we can write 9 by 8 without any error. We can write and minus, oh sorry, so what we can do, this is our equation. So calculate for 1, and this will give us 7 by 6. So 7 by 6, and this will be equal to 9 by 8, 9 by 8, and minus 7 over 6, and this will give us minus minus 1 over 24, and decimal value will be 0.041666. So minus 0.0417 we can write. So this will be the distance, and distance cannot be negative, so distance we will write distance is equal to 0.0417. This will be the positive value which we'll be writing over here. And now we can move to the next question. This is done. Next question is 7. Question number 7 says Question number 7 says a particle P of mass 0.3 kg. So this is 0.3 kg on a rough plane, inclined at an angle of theta to the horizontal. So this is theta, where sine theta is given 7 by 5, 7 by 25. So this is very important value which we'll be using. A horizontal force of magnitude 4 Newton. So magnitude 4 Newton is the force, and they have indicated over here this is the 4 Newton force, which we can highlight like this. The vertical plane containing a line of greatest slope of plane is applied to P. C diagram. So the particle is on the point of slipping up the plane. So show that the coefficient of friction between the particle and the plane is 3 by 4, and this is 4-mark question. So first of all, we can resolve the diagram, and what will be the forces direction of the forces will be, this will be the perpendicular result, reactionary force, so R, and the weight will be acting downward, and if I draw W like this one, so this will be mg, and we can resolve the forces, and this will be x and y component of the force, and this will be angle theta, and we can resolve this force also, because this 4 Newton force is also making some angle, and that is also the same angle, so we can resolve this force as well. We'll have to extend the line a little up to this one. Okay, this is done, and this angle is also theta. So this is the resolution of forces. Now we can resolve the forces along first y-axis. Y-axis, this force will be upward, R will be, no, this force will be downward basically. So we can redraw this line like this one. So R will be upward, and downward force will be 0.3 g. This force will be downward force, and the other downward force will be in this one, because we have resolved it. So this will be the component y-axis. So we can write y component, if we resolve along y-axis, what will the equation? R will be equal to 0.3 g cos of theta. So this will be cos theta, and this one will be sin theta. So similarly, we will discuss this will be cos theta. We will discuss this later. First we just solve y component. So y component will be R is equal to 0.3 g cos theta, and plus y component of 4, this one. This is basically opposite over hypotenuse. This will be sin theta. So this over this will be 4 sin theta. So plus 4 sin theta, and we know this reactionary force is equivalent to 4 Newton, so we can write this is equal to 4, and this we can from now we can basically solve the x component also. So forces acting along x axis will be what? F will be equal to, force will be equal to 4 4 cos theta will be this one, cos theta of this force, and minus 0.3 g sine theta, and we can write F force will be equal to 4 cos theta minus 0.3 g sine theta, and this is equal to 3. So this is equal to 3, and show that the coefficient of friction is this one. So coefficient of friction we have to calculate. So coefficient friction is what? F is equal to mu r, and mu is 4 over 3. Basically, how we are getting this 4 and 3? If you want explanation for that one, I will explain on one side how we are getting this 4 and 3. So sine theta is provided 7 by 25, right? This is our sine theta which is provided over here, and we can write theta is equal to, otherwise what we can do, the simpler way is we can take a triangle and like this one. Okay, like this one, this is our triangle and this is theta, and sine theta is opposite over hypotenuse, so it will be 7 and this will be 25. Now if we apply Pythagoras theorem and to find this base, so we can write 25 squared is equal to 7 squared plus x squared. This one I have taken as x, so x squared will be equal to 25 squared minus 7 squared, so x is equal to root of 25 squared minus 7 squared, and this will be equal to what? This will be equal to, we can take this one squared minus 7 squared, and this is equal to 24, so x is equal to 24. So x is equal to 24. So if we replace value over here, like r is equal to 0.3, g value is 10, and cos value will be what? Cos will be 24, cos theta will be 24 over 25, and plus 4 sine theta will be 7 over 25, and calculate this value. You can write over here, you will get 4, and similarly for this one you can write a step over here, and you can write this will be f will be equal to 4 cos theta, and cos theta will be 24 over 25 and minus 0.3 into 10, and sine theta will be 7 over 25, and this value you will get as 3. Now hopefully you understood each and everything, and this will be equal to what? F over r. So mu, basically, wait, so this is our equation. We need to find the value of mu. This implies mu is equal to what? F is equal to not mu over r, mu r. This is basically equation. This implies mu is equal to f over r, and f is 3 and r is 4, so 3 by 4 will be our coefficient of friction which we had to prove. So this one is done, 3 by 4. Now b part of this question says the force acting horizontally is replaced by the force of magnitude 4 Newton acting up the plane parallel to the line of greatest slope. So find the acceleration of p. Acceleration of p, we need to find the force is equal to mu into 0.3 g cos theta. This is the force, and this will be equal to what? Mu value now we have 3 by 4 into 0.3, and g value will be g value will be what? This will be uh, g will be 10, and cos theta will be 24 by 24 by 25, and we can calculate this value, and this value will be what? We can write this as 3 over 4, and this will be 0.3. We'll have to write multiplication 0.3 and multiply by 10, and this will be multiplied by 24 over 25, and this will be equal to 54 over 25. So 54 over 25, this will be f value. So we are basically, I'm trying to rectify the bracket. Okay, so now we will apply Newton's law. So 4 minus F, force of friction, and uh, minus 3 sine theta. These will be the forces, and this will be equal to ma. So 0.3 into a, and this will be, we can replace the values. Force of friction, which we have basically calculated, this is the force of friction. So we'll replace 4 minus 54 by 25, and sine theta also we know is 54 over 25, no sorry, 7 over 25, and this is equal to 0.3a. Now we can find a value, and a value will be what? We can simplify this side first, so it will be 4 minus 54 over 25, and next will be minus 3 in brackets will be 7 over 25, and bracket close, and this is equal to 1. This side is 1 is equal to 0.3a. 1 is equal to 0.3a, so a is equal to 1 over 0.3, or we can write as fraction 10 over 3. This will be acceleration, so meter per second square. Hopefully you understood this part as well. Now we can move to the C part. C part says, starting with P at rest, the force of 4 Newton parallel to the plane acts for 3 seconds and is then removed. Find the total distance traveled until P comes to instantaneous rest, and this is 3 marks question. We can write down the given data, and we know it's starting from rest, so u will be equal to 0, and acceleration we have calculated in the previous part. Acceleration is equal to 10 by 3 meter per second square, and t is 3 seconds, so t is equal to 3 seconds. Now work done will be equal to what? Work done uh, work done will be equal to force into distance covered. So work done will be equal to force into distance covered. So we require basically force and distance covered. So distance covered we can calculate by S is equal to ut. We have u, we have t plus half into a we have, and t square also we have. So we can replace in this, and we will get 0. S is equal to basically S we are calculating. So u is 0, so this term will be 0, and plus half a is what? A is 10 over 3. A t squared, and t squared means 3 squared, and this will be equal to what? And this will be 15. So this is equal to 15 meters, and now we can find basically this will be F into S. So work done is equal to F into S. So distance is, so 15 basically is the distance. So Fs will be what? Fs will be we don't have F, so what we can do, we can use work done is equal to Fs, and work done is 60. So because it will be, force is this one, 4 Newton, so it is already basically given 4 Newton force, so we can replace, this will be 15 into 40, 4 into 15. If we do this one, we will calculate work done will be equal to 60, right? So work done is equal to, we can write on the equation, this will be in joules basically. So work done by 4 Newton force, work done by 4 Newton force will be equal to what? Will be equal to work done against friction, against friction, plus this will be potential energy gained, plus potential energy which will be gained. So gain in potential energy will be this one. We can replace values in this equation. Work done against 4 Newton force we know is 60. This one is equal to friction is mu and r value, so 0.3 g cos theta into the distance covered is d, and plus this will be 0.3 g d sine theta. This will be the potential energy, basically height multiplied by this. So we can simplify, this will be 60, this side will be 60 is equal to mu value is 3 by 4. So we'll replace this mu value into 3, and this will be basically mu 0 in 0.3 we calculated also, but okay, so we can replace these values over here. 3 into g, which is 10, and 24 by 25 will be cos theta, and d value will be, this d value we can take common because this is in both, so we can write outside, and plus 0.3 into g into sine of theta will be 7 by 25, and this will be d value outside. Hopefully you are getting. Now what we can do, we can send this whole to the other side, and this will be, or otherwise we can just simplify it here. This will be in bracket 3 over 4, and this will be multiplied by 3 into 10 into 24 over 25, and this will be plus 0.3 into 10 into 7 over 25, and bracket will be closed, and this is equal to 22.44. We missed this one, instead of 0.3 we have written 3, so this should be 0.3, and we can calculate separately 3 over 4 and multiply by 0.3 into 10 into 24 over 25, and then plus this will be 0.3 into 10 into 7 over 25, and this will be equal to 3. So 60 is equal to 3d, so d will be equal to 60 over 3, which is equal to 20, and d is 20 meters. This will be distance which we needed to find. Hopefully you understand this. So this is the last part of this paper. We are done with the whole paper. Hopefully you understood each and everything. Don't forget to subscribe the channel. Also recommend this channel to your friends and class fellows and introduce this channel to your respected teachers. Thank you very much for watching. Take care. Bye.